Hello, I'm environmental students. Today we're going to be talking about photochemical smog, and we're going to be focused on the troposphere this time because all the pollutant that makes this stuff is formed where we live, in the troposphere. Alright, let's get started. So before we get started, let's make sure we were really understanding ozone from previous classes. Remember, ozone is O3. It forms when we combine a single oxygen atom with diatomic oxygen, O2, which is what we breathe. Right? Remember that lone oxygen atom doesn't like being by itself, so oftentimes it is being radical, whoa, 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 and it bounces into the O2 and it reforms ozone. Remember that? Alright, so we love ozone when it's in our stratosphere. It makes that protective ozone layer that keeps the sun rays from getting us, like that umbrella or sunblock for the Earth. Alright, so the stratosphere is where ozone is good. That's the ozone layer, and we don't want an ozone hole up there. However, today we're learning that in the troposphere, sometimes ozone is where we live, and actually, that's bad. Troposphere is bad down below. Good up high, down bad nearby. Good up high, bad nearby. Alright, let's learn why. So, ozone in the troposphere. So, ozone in the troposphere is bad because it has a lot of negative impacts. What happens is when troposphere is near us, it can damage crops and forests. So that will affect productivity, amount of oxygen production, how much CO2 is being taken out of the atmosphere by forests, less crops for us to eat. Very bad. It is also an irritant to our eyes. So we like ozone up in the sky, but when it's down nearby and it gets in our eyes, it hurts. More importantly, we frequently are going to hear about it in our class causing breathing difficulties. Ozone nearby can cause asthma attacks, especially for people who are prone to it, but even for people who are not as prone to it. It can cause more susceptibility to infections because it's going to affect your immune system, and it will attack fabrics and rubber. Ugh, terrible. But why is it forming nearby us? Why, where we live, is there ozone? We want it up in the sky in the stratosphere. How is it suddenly getting down near us? Let's talk about it. So, before we can talk about it, we need to have some important definitions. We need to know the difference between a secondary and a primary pollutant. Primary meaning first, it is the first way that pollutant will enter the environment. So for instance, a pollutant that enters the environment directly is NOx or NO, which is nitrogen oxides that come out of car emissions. There's no chemical reactions that have occurred to NOx, it just comes straight out of the car exhaust. That is a primary pollutant because I can see its direct source. This should sound a lot like point source pollutant. A secondary pollutant has gone through a chemical reaction. So that same NOx from the car emissions, if it reacts with water, it'll form HNO3. That's nitric acid. That's acid rain. So the difference again is this is directly from a point source. This is that point source pollutant interacting and going through a chemical reaction, a transformation, and forming something else such as acid rain. Alright, now that we know that, let's talk about where ozone comes in. Well, when there are burning of fossil fuels will have the following primary pollutants, such as hydrocarbons, right? Fossil fuels are mostly carbons, and when they burn, hydrocarbons come off. But similarly, NO, just like that car exhaust was an example, all right? So that's NOx. Well, it's going to come out into the atmosphere, and we can see that in this diagram. We have volatile organic compounds. That's what this VOC is. That's sort of like our hydrocarbons, and we have NOx, and they're all coming out of the factories and the car emissions. Oh my gosh. But somehow they become ozone. Well, if you peek at this little thing, this is how. Well, a secondary pollutant, remember, has to go through a chemical reaction. Well, especially the NO, the NOx, will react with oxygen and it will form NO2. That NOx, all right, NO2, will absorb sunlight. And just like how we saw in our ozone oxygen cycle, an O from NO2 can be karate chopped off, right, by a UV light ray. And when it breaks it off, it'll release a radical O. Oh my gosh, what? Radical O! Oh my gosh. So remember, it's UV light karate chopping off one of those O's, and it releases the radical O. Well, remember, when that radical O is bouncing around, even though it's now in the troposphere doing this, because this is all a pollutant situation happening in the troposphere, well, that O will find a partner, all right? And that partner that's really common in our troposphere is regular O2. But if O mixes with O2, boom, and they combine, what are they going to form? Ozone, O3. And that is now happening in our troposphere. Well, we wanted that to happen in the stratosphere. Do we want it to happen in the troposphere? No. Right? Good up in the sky, bad nearby. So this, because it's gone through a chemical reaction, is a secondary pollutant. O3 is a secondary pollutant in the troposphere. And when we think about this, the mixture of the primary pollutants, those hydrocarbons and the NO, and the secondary O3, we call that smog. So what is this photochemical smog business? Well, photo means sunlight, right? So it's a mixture of the primary and secondary pollutants we just talked about, NO, hydrocarbons, and O3, but it was all formed under the influence of sunlight. Remember, the UV had to hit the NO, and then that's how we got ozone. We've simplified it. There could be over 100 chemicals in that smog. Gross. And they're not all good for us. But the thing that is mostly there that's bad is ozone. Remember, ozone only formed because it went through a chemical reaction. So we consider it a secondary pollutant. Remember, what was the cause? Really, the cause was the point source fossil fuel pollution, mostly from cars or industry. But the interesting thing is, since it's photochemical smog, sunlight, when does this smog peak? Well, it's going to peak right after the AM, during commute times, and on dry, sunny days. Because if it rains, some of these things will fall out of the sky with the rain. And in the AM, there's so many cars polluting, and there's the sun, and they're going to all form that photochemical smog. One bad thing is, in some places, this photochemical smog can stay in a bad situation. And so normally, we worry about this, especially in valleys. So we don't want this to happen. Normally, air, right, the warm air will be at the surface and the cold air will move up. But in a valley, warm air mass, right, will move above, right, and then cold air will go above that, and this can trap pollution in a valley. Oh no. We'll talk more about thermal inversions in class because this is kind of a difficult concept. So what's really bad is, since the warm air is less dense, it sits on top of that colder air, and any pollution it contains will be trapped. So where does this happen again? In valleys, because the air movement over that hilly area is what causes this weird phenomena of the pollution being trapped. So imagine it's kind of like a bowl where people live, and the air is circulating on over and traps that smog right in on that city living in the valley. So where are some places where this happens? Well, especially in California, specifically LA is a big valley, and a lot of places in China where there's lots of hills, this happens, and China is really struggling with smog. So we're going to look at some examples of that in class. So overall, what affects the formation of this stuff? Well, topography, right? Because those valleys can trap the smog in the city. Population density, the more people, the more pollution, the more fossil fuels are being burned, the more hydrocarbons, and the more NO, which forms NOx, which then gets cleaved to form ozone, etc. All right? And then if we're using fossil fuels and not making the decision to use renewables, that will be a problem that increases smog formation. And then local climate, because remember, if it's windy, it might move the pollution elsewhere, but that's not good. But if it rains or snows, it'll at least bring the pollutant down as acid rain. Not the best thing either. but it won't make as much smog. So what can we do about it? So remember our pollution management strategies. Our first one is reduce or change the human activity. So we can reduce those demands for that electricity or fossil fuels by switching to renewables. We could alter human activity by maybe having less private cars. We could do that by having public transit, walking, biking, using car sharing situations like Zipcar. Regulations tend to be focused on the EPA's Clean Air Act, which was formed in 1963 in the U.S. A lot of that is what led to the states, like the Virginia Department of Environmental Quality, having the car emissions tests that you might have had to participate in. Those are going to encourage the use of a really cool thing called catalytic converters that are inside the car, and those things clean the exhaust of those primary pollutants before they even get released. So that allows for less NO to even come out of the pipe, which is going to really reduce the total amount of smog. And that's why if your car doesn't meet the requirements, it's really important that you get it fixed, because otherwise you're creating a lot of air pollution for everyone. And then fuel quality, the fuel should be the right grade of fuel, because if it's not, then it can lead to more pollution. Lastly, restoring the environment. There could be some ways that if we have had some problems that are affecting the forest, we could reforest, we could regreen, we could try to sequester some of the carbon dioxide. But overall, the restoration for this is really hard. Getting rid of the pollutant when it's already out there is really not a great solution. So we really, for especially air pollution, try to focus in on the top two options. Great job, guys. See you in class.